Hello, this is Mr. Stansbury. I'm going to take you through the notes on transforming the absolute value parent function. At the end of this, you should be able to say, I can identify the effect of the graph of replacing f of x by f of x plus k, k times f of x, f times k of x, and f of x plus k, so k being a variable. And then also you should be able to say, I can find the value of k given these graphs. Okay, so first things first. So first thing we've got is parent functions. These are the most basic functions of a particular type. So for example, this is our the parent function of a linear graph. It's just y equals x. It's the most basic form. It doesn't have a number in front. It doesn't have a number after. It's positive. Here's y equals x squared. And the one that we're going to be dealing with is y equals absolute value of x. Okay, now, there's obviously several ways to graph, but once you know what the absolute value of x graph looks like, then we can actually transform those, and we can slide them and move them up and down depending on what's going on with these things over here. So just to kind of remind you, on a t-chart, we could do, like, say, here's our x, and instead of putting y, I like to put y actually equals, so then this would be absolute value of x. So we usually like to do -2, -1, 0, 1, and 2, right? So if we put in 2, absolute value of 2 is 2, absolute value of absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. And that's where all these points come from. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Okay, but again, you don't have to make the t-chart once you know what the graph looks like. Okay, let's do this. Oops, I'm going to pull this up. We're going to look at a bunch of different graphs here. Okay, now this is a this is a funky notation I had to put on my graphing program here to show you, but what you want to look at is this stuff over here. So y equals absolute value of x, or f of x equals absolute value of x, same thing. So this is the graph of the absolute value of x, just like what we have, what we had back on the previous slide, right? Now, I'm just going to show you what happens when we start adding things into this. So this is, look over here to the right, kind of ignore this over here. The next thing we're going to look at is absolute value of x plus 1. Now, if you think about it, you're just adding 1 to all the y's, so hopefully it would make sense that when we show that, the whole graph just moves up 1, because you're taking, say, absolute value of 1 is 1, but then you got to add 1 to that, so now you're up at 2. Okay? So this number that's outside here is going to make the graph go up or down. Hopefully it would then make sense with this absolute value of x minus 2 that the whole graph is going to go down 2, right? Because you take absolute value of 1 is 1, and then you subtract 2, and there we are. Okay. Now, if we turn those off there, and then we're going to look at what happens if we put numbers in front. So now we're, like, let's say if we had absolute value of 1 is 1, now we double that, and now we're up at 2. But now if we do absolute value of 0 is 0, and we double that, we're still at 0. So now it's going to go up. Basically, it's just going to affect the slope of these lines, as you can see. Right? The absolute value of 2 is 2, but then you double that, and now we're up to 4. Okay, same idea with this 4 out front here. Now it's going to go up 4 times as fast. So absolute value of 1 is 1, but then we got to multiply that by 4, so now we're up at 4. Okay? Now with the same idea, now we have half of x. So absolute value of 1 is 1. Half of that is going to be out here. And absolute value of 0, half of 0 is still 0. Now we're going to get this line that comes out a little bit flatter, right? Just like so. Okay? And then an interesting thing that can happen here is put a negative in front. So again, with absolute value of 1, we get 1, but then we have to multiply that by -1, so now it actually ends up down here, and the 0 is still here. So now the graph basically gets flipped upside down. Okay? All right. let's take a look at what happens to these graphs when we put some numbers inside. So now we have absolute value of x plus 2. So let's take a look. If we put in 1, absolute value of, if we put in 1 here, we got 1 plus 2. It's actually 3. So if we put in absolute value of 1, excuse me, we actually get 3 up here. If you put in absolute value of 0, we actually get 2. If we put absolute value of -1 in there, -1 plus 2 gives us 1. -2 gives us 0. -3 plus 2 actually gives us absolute value of -1, which is going to be here. So basically, look, this whole graph is getting moved over to the left. Okay, even though it's +2, the whole graph actually gets moved over to the left. Okay, so hopefully by that same idea there, if we have a negative in there, it's actually going to go to the right 3. So we just shift the whole, so these numbers inside here are going to shift it left and right. Okay. With this absolute value of 2x, we put that in there and it's like, hey, wait, we did that already. That's the same exact graph as this one. So when I graph that, pull that one off, it's the exact same graph. So really, whether the number is inside or outside, as long as it's positive already, it's not going to have really any effect. If it was negative on the outside, that would have a different effect as negative on the inside, but we're not going to worry too much about that. Okay, so turn that one off. If we have absolute value of -2x on the inside, guess what? Still the same graph, because that negative gets the absolute value taken of it. So it's still ends up being looking the exact same as the regular absolute value of 2x. Okay, and absolute value of 0.5x is going to be this thing here, which is the same as this one up here, right? We click on that one, and that's the same graph. Okay, so that kind of gives you an idea, hopefully, of what all of these functions up here, all of these do. Now, what we're going to do is we're actually going to take that. Here's a bunch of letters and numbers. All the white stuff is the stuff that's going to show up in every single one. Y equals, and then absolute value of x, blah, blah, blah. But we had numbers in 4 different spots, so we're going to kind of take a quick peek as to what each of those numbers are going to do. Okay, so if positive or negative here in the front, the graph is going to either open up or down. If it's positive, it's going to open up. If it's negative, it's going to open down, right? So back to this here. So if we had negative out front, opens down. If it was positive out front, which is this original one, it opens up. Also, so does 2, so forth and so on. So that's what this does. The A here is going to be the slope of the lines of the graph, basically, right? So when that turned into, remember when that turned into a 2, the slope is, instead of up 1 over 1, up 1 over 1, now it's up 2 over 1, up, like, say, on this other one here, it's going to be actually up 4 over 1, and it's going to go each way. It's going to kind of mirror image right over the top of the y-axis. Okay? So, next thing we got on here is the B is also going to, it's, remember from back here, that if whether it's inside or outside, oops, let me get that, let me get this back, there it is. So whether the 2 was on the inside or the 2 was on the inside or the outside, they end up being the exact same graph. Okay. And let's see. Next thing we have, remember, if we had a positive in here, the whole graph shifted to the left. If we had a negative, the whole graph shifted right. That was these. I just got to leave this other thing on. Sorry, I hope I'm not making it too dizzying for you guys. Oops, I wanted that on. So if this was a negative, remember that negative actually made it shift to the right 3, and if it was positive, it actually made it shift to the left 2 on this one. Okay. All right. Next one is This plus here on the outside shifts the graph up d units, and the negative on the outside shifts the graph down d units. Okay? And also, sorry, back on this one here, to the left c units, and to the right c units if it was negative. So up if it's positive, down if it's negative. Excuse me. And that is these up here, right? So the whole graph goes up if it's positive, whole graph shifts down if it's negative. Okay? And that pretty much takes care of these here. We're going to take a look at we're going to graph some examples here really quick, but before we do that, let's take a quick comedy break. Oh man, let's try that again. I think I got it to work again.
Where are you going? Where are you going?
All right. All right, let's graph a couple of these here. So we're going to sketch the function. So remember, absolute value of regular old x, just maybe to make this a little bit easier, I'm going to just put the absolute value of x on this, at least the first graph here, so you can kind of remember what it is. So remember this, if the number is outside of the absolute value, it makes it go up or down, and that's -2, so the whole graph is going to actually go down 2. Right, so this whole graph just gets shifted down 2, so it should end up looking like that. And again, if you like forget and you're like, what the heck's going on, I can't remember what happens, you can always start graphing. You can always do a little t-chart to kind of start get you going, but really your best bet is to look at that little chart that we just went through on the last page of notes there. Okay, f of x equals -2 square root x. So remember, excuse me, if there's a negative out front, that means it's going down, and then it's got a slope of -2 over 1. So we're still going to start here at 0, 0, and we're going to go down 2 to the right 1, and then down 2 to the left 1 on the absolute value, and that's basically what that's our slope, if you'll remember. And this one here goes that way. And that's what our graph's going to look like. Okay. Now remember, if we put it on the inside, that absolute value of -2, that negative turns back to positive. So we end up, basically that's just going to be a +2 over 1. So we're going to, from 0, 0, we're going to go up 2 over 1, up 2 over 1 the other way. And now we graph this thing. Give it a sketch. And we're good to go. And these don't have to be perfect. As long as you've got the right idea, you're showing me the points and stuff on there, we should be good. Okay. Absolute value of x -2. So remember, this negative means that whole graph's going to actually go to the right. What I like to think of is what's going to make this equal to 0. What do I put in for x so that this equals 0? Oh, I put a +2 in there, so I know, oh, this whole graph goes positive. It shifts to the right too. So we do that and then go straight up that way and then straight up that way, and there's our graph. Okay, one last quick set of examples to look at is now we have the graph. Now we're going to write the equation for the absolute value function. Okay, so y equals let's see, the slope on this thing is up 1 over 1, right? So you really can kind of look at a couple different things. One, out front, if it was opening down, it would be negative. It doesn't, so it's positive. It's opening up, so that's positive, sorry. And then we've got the slope comes next, right? So we can put a slope in there of 1, or you can just leave it off because 1, if there's no number out front there, it's just assumed that it's 1. And really the whole graph is just going up 4, it looks like, right? So it's absolute value of x, and up and down shift has to be outside of the absolute value. Okay? So probably our best bet is that right there, absolute value of x, whole thing shifts up 4. Okay. On this next one here, it doesn't look like it shifted left or right or up or down, but it has gone, like the slope now is up 1 over 2. So now we have y equals, and then we can put, say, positive 1/2 out here, or we can put 1/2 inside with the x. But this 1/2 out here will work just fine. And remember, this piece out here is the slope. So up 1 over 2, up 1 over 2, and then it hasn't shifted anywhere from there as well. This g here, if you'll notice, it's basically the normal graph here, but now it's just upside down. So that means it's just negative absolute value of x, right? Because the negative takes the whole graph and flips it upside down. Okay? And then this last one here, we've got y equals, this whole graph got shifted 1, 2, 3 to the left. So 3 to the left, we're going to do x. And then basically what I'm thinking of is this x here is negative 3 because it shifted to the left 3. So what do I do to make this equal to 0? Plus 3. So then that ends up being our graph right there, or the equation of our graph, because the whole thing shifted to the left 3, which is x plus 3. Okay? All right, that's all we have for transforming the absolute value parent function. If you have any further questions, please feel free to ask. Thanks.